Okay, let's work out a few examples here where we're going to look at the Lewis structure, its shape, if the overall molecule is polar or nonpolar, bond polarity, and what IMFs are present. So remember, when we're talking about IMFs, those are our intermolecular forces, and that's what's pulling some of these molecules together. We talked about them before when we talked about phase changes, solid to liquid, liquid to gas, that type of thing. But now we are looking at them on this smaller scale and how they are behaving, what is actually causing them to do that. So let's go ahead and look at some examples. Let's check this first one out. Let's do fluorine. We got F2. So when I'm working with F2, I know I have 2 fluorines. They each have 7 valence electrons. So I have 14 to work with. There's no central atom here because we only have 2, so I'm going to bond those together. So I got 12 left to work with. And I've used all 12. And each fluorine has 2, 4, 6, 8. We're good to go. These are the same elements, so I cannot draw any bond polarity because they are pulling with the same force. Since these are the only 2 elements involved in this compound, then we don't even have the option for it to be polar. So we know that this is going to be nonpolar. Because of this shape, our only option here is linear. And then we need to talk about what intermolecular forces there are. If you draw a molecule, it automatically has London dispersion. I abbreviate London dispersion LD. Dipole interactions has to be polar. Dipole, 2 poles. Since this is a non-polar molecule, I cannot have dipole. Last one's hydrogen bonding. Hydrogen and NOF. Nitrogen, oxygen, or fluorine. Well, there's fluorine here, but it's not bonded to any hydrogen, so that cannot be an option. So, no bond polarity because they're the same. A nonpolar molecule, it's linear and it has London dispersion. Let's talk about our next one, carbon tetrahydride. Carbon brings 4 valence electrons to the table. Then I have 4 hydrogens, each bringing 1 to the table. So I have 8 total valence electrons to work with here. Go ahead and do my single bonds to each one. 2, 4, 6, 8. 2, 2, 2, 2. All of my hydrogens are happy. 2, 4, 6, 8, and my carbon's happy. So I am done drawing my Lewis structure. So let's take a look at our bond polarity. So I'm looking at who is more electronegative, hydrogen or carbon. Well, when we're looking at our periodic table, carbon is closer to fluorine than hydrogen is. So all of my polarity arrows are going to be pointing into carbon. And yes, you do have to draw polarity arrows for each bond because you're talking about the polarity of that bond. So if we're talking shape here, I have 4 things bonded to it. So for our shape options, we know our only option is tetrahedral. Now let's talk about our overall polarity. First question, are there lone pairs on the central atom? So are there lone pairs on carbon? Nope. Next question, are the peripheral atoms different? So are these different? Nope. I say no to both, that means that it's non-polar. Now let's talk about our intermolecular forces here. So I drew it, so it has LD. It's non-polar, so it cannot have dipole. Remember, dipole has to be polar. And then let's look at hydrogen bonding. Remember, hydrogen bonding has to be hydrogen bonding has to be between hydrogen and nitrogen, hydrogen and oxygen, or hydrogen and fluorine. This is a hydrogen and carbon, so it does not have hydrogen bonding. So this is our final answer for this question. Okay. Let's look at our next example. Let's do water. So, hydrogen, we have 2 of them, each bringing 1 valence electron to the table. And then we have 1 oxygen, and it brings 6 valence electrons to the table. So I have 8 total. Oxygen's going to be my central atom. I'm going to bond it to my hydrogens. So that's 2, 4. So I have 4 left to use. 2, 4. Remember, I did not put those lone pairs on my hydrogens because my hydrogen only wants 2 valence electrons there, and it has that. So let's go ahead and check out our bond polarity. Oxygen's closer to fluorine. So for both of my arrows, we will be pointing towards oxygen. Let's talk about our shape here. So there's 2 things bonded to my central atom. So my option is either linear or bent. Remember, my question between linear or bent is, does it have lone pairs on the central atom? This one does. And remember, if we have lone pairs on the central atom, then that makes this a bent molecule. Now let's talk about overall polarity. The first question on my flowchart is, are there lone pairs on the central atom? Yes. So then it's polar. We don't even have to go to the next step on that one. We could draw the Lewis structure so we know it has London dispersion. Dipole means that it has to be a polar molecule, which it is. So it has dipole interaction, which I abbreviate as Di. And then we need to check for hydrogen bonding. Remember, hydrogen bonding can happen between hydrogen and oxygen, hydrogen and nitrogen, or hydrogen and fluorine. Any of those. This has hydrogen and oxygen, so this qualifies for hydrogen bonding, which I abbreviate as HB. So this is bent, polar, and has all 3 intermolecular forces here. Let's check out another example. CH3Cl. So carbon brings 4 valence electrons. Plus I have 3 hydrogens, each bringing 1 valence electron. Plus I have my chlorine, which is bringing 7 valence electrons. So total I have 14 to work with. Remember, if carbon is there, we're always putting carbon in the middle. I'm going to go ahead and put carbon. And I'm going to go ahead and bond my 3 hydrogens and my chlorine. And that's 2, 4, 6, 8. And that leaves me with 6 valence electrons to put somewhere. My hydrogens are happy because they all have 2. So I'm going to go ahead and fill in my octet for my chlorine here. We got 2, 4, 6, 8. Chlorine's happy. We've used all 6 of those. So let's check in on our central atom here. 2, 4, 6, 8. We're good to go. So we have now got our Lewis structure. Let's talk about bond polarity. Now we saw earlier in our carbon tetrahydride that between carbon and hydrogen, our polarity arrow was pointing towards carbon. So I'm going to go ahead and do that for our 3 hydrogen carbon bonds. So now I need to look at carbon versus chlorine. Now remember, chlorine's behaving more like that fluorine. It's going to be holding that electron more. So chlorine is going to pull that electron to it more of the time. Remember I gave the example with these ions that these electrons. That it belongs to both of these, but it may spend more time with this one than the other. Okay. If you have parents that are divorced, you may spend 5 days at one parent's house and 2 days at the other. They're still both your parents, but the amount of time you're spending with them may be a little bit different. Okay, that's how these electrons are behaving in polar bonds. So let's look at this shape. 4 things are bonded to it, so our only option here is tetrahedral. We are going to look at our overall polarity. First question, are there lone pairs on the central atom? So we're looking at carbon. No lone pairs, so no there. Are the peripheral atoms different? So are these different? Yes. So we are polar. So this is a polar molecule. We were able to draw it, so we know that there's LD. It's polar, so we know we have Di. And then we need to check for hydrogen bonding. Is there a bond that's between hydrogen and nitrogen, hydrogen and oxygen, or hydrogen and fluorine? No. This is between hydrogen and carbon. That does not qualify for hydrogen bonding. So we're only looking at London dispersion and dipole interaction. Let's do one last example here. Let's do nitrogen trihydride. So NH3. So nitrogen is going to bring 5 valence electrons to us. We have 3 hydrogens, each bringing 1. So we're going to have 8 total valence electrons. Nitrogen is my central atom. I'm going to do my single bonds there. That's 2, 4, 6. Got 2 valence electrons left. Hydrogens are already happy. 2, 2, 2. So we're going to use those 2 valence electrons and put a lone pair onto nitrogen there. So now I've used all of my electrons and I have my Lewis structure set up. So let's talk about bond polarity. Between hydrogen and nitrogen, nitrogen is closer to fluorine. So those electrons are going to stay with nitrogen more. So finished drawing my bond polarity arrows. Let's talk about our shape. So I have 3 things bonded to it. So my options are going to be trigonal planar or trigonal pyramidal. My question there is, are there lone pairs on the central atom? Yes, I have these lone pairs on the central atom. That's going to push my bond down. So this is going to stand up like a pyramid. So this is trigonal pyramidal. Okay. Let's talk about our overall polarity. Are there lone pairs on the central atom? Yes. If I say yes, then I know this is polar. And then let's talk about our intermolecular forces. We drew it, so we know it has London dispersion. It's polar, so it has dipole interaction. And then we need to check for hydrogen bonding. Remember, hydrogen bonding has to be between hydrogen and nitrogen, hydrogen and oxygen, or hydrogen and fluorine. Does this molecule have any of those? Yes, we have 3 hydrogen-nitrogen bonds, so this also has hydrogen bonding. So that's a pretty good overview of connecting our Vesper shapes, polarity of bonds and of molecules, and then those intermolecular forces.